Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'm Quentin and I'm joined by Sana and Gagan, and we'll be your host this evening, broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, or Tuesday morning at 1 a.m. Universal time. The York Universe production in concert with our online public viewing programs run by the Observatory team, which runs between the hours of 9 p.m. to 10 p.m. local Toronto time. You can go to www.yorku.ca/science/observatory and follow the links to OPV, online public viewing, and join the chat right now. You can always connect with us on Twitter with our handle @York Observatory or Instagram with the handle @YorkU Observatory, and Facebook at Allan Carswell OBS. All of our programs are free, but if you would like to make a donation, please see our website. Once again, that's at yorku.ca/science/observatory. So the current weather is about 1 degree, partly cloudy where I am. I am actually located on the opposite side of the Oak Ridges moraine from Toronto. I wonder, Gagan, Sana, what's the weather like for you? Are you getting different conditions? How's the viewing?
Terrible.
Oh,
yeah.
You hate to see it.
Yeah. It was actually looking kind of promising for tonight earlier this week, but in the past, today has just deteriorated a lot. So unfortunately, no live observing for us.
I don't suppose. Oh yeah, go ahead.
Sorry, I was just going to say there's a bit of cloud cover around campus. I just left about half hour ago.
I don't suppose you were able to get any kind of view of the partial lunar eclipse that happened on Saturday night, were you?
No, actually.
Yeah, I didn't
No?
see it.
Yeah, that's all three of us struck out. And it's a shame because it was a really good full moon that night too, from what I saw. I even set a reminder on my phone that it was going to happen. And then I got the time mixed up. I thought the time it was ending was the time that it was starting. So I was like, oh, I've got a little bit of time. I can wait a bit before I go outside. And by the time I did go outside, it was completely, there was nothing to see. I did hear though that by the time the moon would have risen for Southern Ontario, we would have been out of the full the partial eclipse stage. It just would have been penumbral anyway. So I get maybe this is just sour grapes, but maybe we weren't missing all that much. I don't know. Maybe some other people in the chat or listening to this broadcast may have been able to see more of an impressive sight. We've still got that solar eclipse coming up in April though. So mark that on your calendar.
I actually got the chance to see partial solar a few weeks ago when it wasn't actually visible here, but at the time I was in Mexico for my cousin's wedding.
Wow.
So, and
you just happened to be in Mexico. You didn't even go there for the eclipse.
I didn't go there for the eclipse, and I found out while I was there, and we got about 80% coverage. So we had
fantastic.
Oh yeah.
Yeah, it was pretty great. But I didn't have my eclipse glasses on me, so I only got a little glimpse of it when I borrowed somebody else's.
Ooh.
Yeah.
All right. Well, that's still not bad. It's still not bad. I've got a pair of eclipse glasses in my car that I'm saving for this. They even have the date written on the side of them, although I don't remember just off the top of my head what it is. Do either of you guys remember?
The upcoming solar eclipse?
Let me look it up.
Yeah.
April 8th.
Got it.
Yep.
April 8th. All right. Save the date, everybody. That's the next that is the next total eclipse that you might be able to see if, like us, you live in Canada. It's always an exciting time. Remember, don't look at it with your naked eye or with an unfiltered telescope. That's a good way to damage your equipment.
Yeah. Oh, it's going to be a great time too. It's like 3 p.m.
Oh, that's perfect.
Yeah.
Okay. I don't even have to get out of bed early. I love to hear that.
I know, it's great.
Yeah, I'm fairly certain the observatory is going to be doing some sort of viewing event for this. We won't have a total eclipse in Toronto. We'll be like, I think, missing something stupid like only 1% away from a total eclipse. But if you're in the area, I'm pretty sure we're going to be doing something for this.
One of the other people who works at the David Dunlap Observatory with me, she's taking that entire week off and she's going on a road trip to, I think, Montana or something like that, just so she can be in the path of totality. So I wish her the best of luck with that. I that's a really exciting thing to do.
Yeah, because you don't even have to drive like that far, even from Toronto, to be able to see it. I think if you just go to the Simcoe Hamilton area, you should be in the path of totality.
Oh, okay. She's being extra then. I don't know why she's going to the States. Fair enough.
Maybe she just wanted to go there and decided to
Yeah,
make a trip out of it, right?
Yeah,
Fair
it
enough,
says
fair
for
enough.
Toronto, in Toronto, we're at 99.8% coverage. So
Yeah.
that's basically totality.
That's fine. That's fine. I can accept that. I can
I'm not
definitely
road
accept that.
tripping for that one.
Oh, I think I'm gonna road trip for that because if you're even that like 0.2% off, you don't get to see like the corona and everything around the sun. So like there's
Oh,
still no point where it's safe to look at the eclipse with the naked eye. You have to be in like that 100.00 percent totality for that.
oh, damn. Okay, maybe I will go to Hamilton then.
Yeah, so considering it's like so close to us, it's just like I'm gonna do it just for that eclipse.
It's not even a road trip. It's just like a little road venture. It's just
Yeah.
a
An
little,
excursion. Yeah.
exactly, a pit stop. Okay,
All right. Do you
amazing.
guys want to get into the meat of the episode?
Totally.
Yeah, that's probably a good idea.
I mean, I can talk about eclipses all day.
Mhm.
But we don't have one happening. So might be a bit misleading.
I mean, if we have a bit of time at the end of the show, we can always come back to eclipses.
Sure, that's a nice spooky topic for Halloween.
Yeah. Yeah, so I think I'm first up in this week in space and astronomy history. So this is sort of two this week in space and astronomy history items combined into one because it has to do with like the beginning and the end of the Arecibo Observatory. So the first part of this news story or this item is specifically November 1st, 1963, which was when the observatory opened. Now, Arecibo was this 305-meter diameter radio telescope that was located in Puerto Rico. It was a single dish radio telescope as opposed to some of these larger radio telescopes, which actually use arrays of smaller dishes that work together as one big radio observatory. Arecibo was just a single dish. It was constructed in this natural sinkhole in Puerto Rico, and it basically just stared directly up at basically one location in space. Then if you wanted to be able to, in a way, point the observatory to different locations, there was a big science platform that had been suspended above the dish of the observatory that could move around to kind of accomplish that in a way. For a very long time, Arecibo was actually the biggest single dish radio telescope in the world, except in 2016, the FAST radio telescope in China became operational, which had a 500-meter diameter single dish, which took the place of first place for the biggest radio observatory in the world. But anyways, an interesting piece of history for the Arecibo Observatory was, even though it had been used for science for basically all of its life, it wasn't actually built for the purposes of doing radio astronomy. It was more specifically built by the United States Department of Defense because they wanted a way to be able to monitor incoming missiles that could be a threat to the United States, basically. So the Department of Defense kind of came up with this idea to create this really big radio telescope that could observe the Earth's ionosphere to be able to pick up on signals of these missiles that could be a threat and be able to kind of intervene those missiles from the start. So that was one of the major motivations for building the Arecibo Observatory, that in combination with it being just a massive radio observatory that could be used for science. So from when it became operational on November 1st, 1963 to around 1969, it was used for both of those purposes. But in 1969, the ownership of Arecibo was given over fully to the United States National Science Foundation, which provided funding for the observatory to specifically just focus on science instead of monitoring for missiles like it had been doing for the observatory. Did so much really cool science and touched in a whole variety of different areas of radio astronomy. I'll just list a couple of some of the, I guess, more major discoveries or things that Arecibo has been known for, but this is not a comprehensive list. It has done many, many more things than just this, but just because for the sake of time, I'll only list a couple. It was used to study planets in our solar system and also near-Earth asteroids. It was able to map the surface of Venus in radio waves, which is not something that you can do in optical or visible light because the atmosphere of Venus is so thick and it absorbs all of those light waves. So you have to use radio waves for this. It was used to, first of all, discover the first binary pulsar system in the galaxy, and which was then used to confirm predictions of general relativity. This was a really major discovery and actually won the Nobel Prize in 1993 for the Nobel in Physics. It discovered the first millisecond pulsar, discovered repeating fast radio bursts, and also discovered the first exoplanet in orbit around a pulsar in 1992. A couple of other interesting things that Arecibo did during its lifetime was that it transmitted the Arecibo message in 1974, which is basically a message to aliens that might be living around the Messier 13 globular cluster. So it transmitted that message in radio waves, not really totally to communicate with aliens. It was a little bit of more of a technology demonstration than it was anything else. But the message was still a good message. And if it was picked up by any aliens that happened to be in that area, it would have contained information on humans and what Earth was and what we were. It also made an appearance in the movie GoldenEye. So if you've ever seen that movie, you have also seen the Arecibo telescope. Now, that was kind of the first part of this Week in History item, was the opening of Arecibo. But if we fast forward about 57 years to December in 2020, or actually November in 2020, which was about 3 years ago now, this was also kind of the beginning of the end of the Arecibo Observatory. So like I mentioned before, there's this big 900-ton science platform that had been suspended above Arecibo. This was held in place by 3 different cables. And unfortunately, Puerto Rico gets a lot of storms and hurricanes. And over time, these hurricanes basically damaged some of those 3 cables that held up that science platform. It was something like it was a known problem. Engineers had been kind of studying it and trying to figure out how to fix the problem while, not causing the platform to collapse. And it was an issue that they had been working on fixing. But before they had a chance to, in November 2020, these problems started to get a lot worse. One of the cables snapped, and then about a month later, another one of them had a major issue that ultimately resulted in this science platform collapsing onto the dish, completely destroying it, and that was the end of the Arecibo Observatory. Unfortunately, the National Science Foundation announced not long ago after the collapse of Arecibo that they would not be rebuilding it and would not be increasing their funding. So unfortunately, Arecibo is no more after 57 years of amazing science and appearances in movies. But yeah, I guess happy birthday to the Arecibo Observatory on November 1st, 1963.
Pour one out for Arecibo. You will be missed.
Yeah, I was so sad when I heard that it had collapsed.
Yeah, for real. I was really disappointed to hear that they couldn't even like repair it. That's really unfortunate.
Yeah.
But it's one of those things, it accomplished a really important job. And all things eventually come to an end. It is sad, but all of the data that we were able to collect is still going to continue to be valuable to us, and still going to be we can still analyze it years and decades in the future. So I guess in kind of a poetic way, nothing really ever dies in science, because even once a mission is done, or once you no longer have access to a piece of equipment, a lot of the data processing from it still takes years to complete.
Absolutely. Yeah, I will occasionally come across an article from something like Cassini or the Sophia telescope, where it's like, yeah, these things have not been operational for a while now, but we found something new in their data that's really cool. So Arecibo will definitely continue to work, even though it's no longer there.
Speaking of things that continue to work, I've got, how's that for a segue? I've got a This Week in History article here. So tomorrow marks the 23rd anniversary of the launch of the Soyuz TM-31, which was the first expedition to the International Space Station, and it occurred on Halloween, October 31st, 2000. So the TM-31 was the first Soyuz of many space flights to dock with the International Space Station, where its 3-person crew stayed for 136 days. The mission was a joint venture between NASA and the Russian Space Agency, and consisted of Russian cosmonauts Yuri Gidzenko and Sergei Krikalev, as well as American astronaut William Shepard. So the Soyuz series of spacecraft is an absolute powerhouse in the history of spaceflight. It's been in service since 1967, and it's participated in over 140 flights. I think it's fitting that the first expedition of the ISS would take place aboard a Soyuz, because the Soyuz would end up becoming the only means of transporting crews to the ISS after the Space Shuttle program was retired in 2011. So this would remain the case until the 2020 demo flight of the SpaceX Crew Dragon. So for about 9 years, the only way astronauts could get to the ISS was aboard a Soyuz spacecraft. And the Soyuz series remains in service to this day. It is one of the primary ways that we still continue to take astronauts up to the International Space Station.
That was definitely the perfect segue.
Thank you. Yeah. So speaking of things that remain in service, right?
Yeah. I mean, it's great that we now have the new SpaceX crew missions, or the crew spacecraft, to be able to launch to the ISS. But yeah, the Soyuz always comes up whenever you read about anything ISS history related. It's always the Soyuz up there.
And it's always been a reliable craft, you know what I mean?
Mm-hmm.
Yeah, my dad would probably make a joke about all the that sounds like something built in 1967. You build it 50 years ago and it's still in service today.
Yeah,
my dad's always been a fan of classic vehicles.
Yeah, I've read a lot of, or at least some sort of interviews with astronauts who have flown on both like the Soyuz and the space shuttle, or even like the Soyuz and the Crew Dragon spacecrafts. And they always kind of say like the Soyuz is definitely, it's quite something. It's kind of a rougher ride than the other spacecraft, but it is very reliable. So I mean,
yeah, that's what I've heard as well.
Yeah, I don't think you can really complain. Like, you make something so reliable and it works so well, but not exactly comfy.
There's something to be said about old things that just last forever. Like, I don't know have your parents ever said this about appliances? Like, stuff that you bought in the 80s or the 90s will continue to work to this day. But if you buy a similar appliance last year, it's going to need repairs tomorrow.
Yeah. My parents talk about that all the
time. Yeah.
It's true, though.
It is
true.
They just don't make things like they used to make them. Like, let's make more Soyuz themed things.
So some appliance company needs to launch their like Soyuz chain of appliances, like a Soyuz
Yeah,
fridge and Soyuz.
I need a Soyuz
They'll have
washer and dryer.
Yeah,
they'll have my business.
yeah.
They will. They will. Totally. Okay, I think I have the next one. Unfortunately, this thing is not working anymore, and this thing is Pluto being called a planet. So, unfortunately for everybody here, um, Pluto isn't a planet anymore. I know we have some believers at the observatory, we have some non-believers at the observatory, but that's the official word. But what I'm here to talk about is the discovery of two of Pluto's moons. So around May 2005, New Horizons was up and coming. It was going to be the next big spacecraft that was going to be sent out to the outer solar system. And in preparation for the launch, Hubble, as well as the Pluto Companion Search Team, were basically focused on Pluto for a really long time. And they were looking for any new or natural satellite. So Pluto was, of course, a really hot topic in the astronomy community at the time. It's the furthest planet from the solar system, and because of the really exciting up and coming New Horizons mission, we wanted to know as much about it as possible before we sent the craft out there. And so by the time New Horizons was getting ready to go, Pluto's biggest moon, Charon, had already been discovered, and Hubble's search for more did not disappoint. Two more very small satellites, kind of asteroid-sized. They were both discovered using images of Pluto taken by Hubble in May 2005, and these were named Nix and Hydra. They're both much dimmer than Pluto, so Hubble had to make extra long exposures to visualize them. And interestingly, both moons were independently discovered by two different astronomers later that same year, because NASA didn't actually make the announcement about Nix and Hydra's discovery until about 5 months later on Halloween 2005. So they were discovered in May, but they weren't announced until October 31st. And within those 5 months, two other astronomers both discovered Nix and Hydra independently and made the announcement. And that's when NASA released the images. So in keeping with the underworld theme, and this ties in with Halloween pretty nicely. Pluto, of course, is the Roman god of the underworld, Greek counterpart to the Greek Hades, and Charon is the ferryman of the River of Styx, which is the river that all the dead souls go through in the underworld to get to where they're going to stay for the rest of eternity. So to keep with the underworld theme, Nyx is the Greek goddess of night, and Hydra is a 9-headed underworld sea monster with, you cut off one head of Hydra and two more grow back in its place. So pretty cool names, kind of on theme with monsters, Halloween, the underworld. So pretty cool discovery.
Yeah, it's really interesting. I like the naming conventions that the IAU always sticks to for these astronomical objects, but I just can't imagine being on some of these teams of astronomers who thought that they had the first discovery of two new moons of Pluto, and then
and then Hubble is like, actually, I had it first. Sorry, guys.
There are so many examples of that in science. Like literally, like some guy just visually published a paper like a day earlier than someone else, and then they get the credit.
Yeah.
And the crazy thing is nobody discovered the moons for years and years. And then within 5 months, 3 different researching bodies all discovered them at the same time. But I will say it kind of makes sense because New Horizons was coming up and the launch was coming up, that a lot of people would be looking at Pluto just, because it was on their mind. But yeah, it sucks for them. But at least they get acknowledged in radio shows like ours, where I did not include their names, but kudos to those guys, those peeps.
Yeah.
I've always thought, the Pluto system's pretty crowded. I guess I shouldn't be surprised because there are all these like trans-Neptunian objects out there. A lot of material that just kind of ends up I guess eventually finding its way together and ending up in orbit. But like, I was always surprised that like Pluto has this like small army of moons, and like all the inner rocky planets. Earth has one, Mercury and Venus have none, and Mars has these two tiny asteroids. Like I don't what's going on in the Pluto system?
Well, I think part of it is because it's so small, right? Because
Hmm.
it doesn't have the gravity to just absorb them
Oh, that
that
makes a
other
lot of
planets
sense.
would have. And the other thing is that that's part of the reason that they declassified it, because Charon is such a big moon comparative to Pluto's size that their like mutual center of gravity is not even within Pluto's body.
Yeah, that's crazy.
Yeah, so that's one of the reasons it was declassified from planetary status,
Wow.
because I think one of the rules that they put in place for a planet to be considered a planet was that it had to have its own center of gravity within its orbital system.
I did hear that the issue with Pluto is that it crosses it crosses Neptune's orbit, so it's not like the dominant body in its own orbit.
Yeah.
I do wonder if it's like kind of a consequence of that, like the fact that you have Pluto isn't able to exert this dominance over its orbit, kind of like leads to this situation where it's not even really able to fully consolidate its moons and become the dominant center of gravity there. Um,
Yeah,
I
I
don't know.
mean, for that,
I'm speculating entirely here. I should I don't know. It might be interesting to study the orbital mechanics of this.
they listed a bunch of different reasons. I think they had to, because when the decision was made, they were met with so much backlash that they had to be like, listen, these are all the reasons why Pluto can't be
Yeah,
considered a planet. Here are all the things that
still
it doesn't
defending that
share with the
decision.
rest of, yeah. Well, they will be forever. But yeah, so part of it definitely is the fact that it's not the dominant body in its orbit. Like it 100% is Neptune, and it crosses Neptune's orbit. But then the fact that it can't even be the dominant body in its own little moon system, because Charon disrupts its own rotation so much.
Or
Hmm.
maybe it's just putting together an army to attack the Earth because we declassified it.
You might be onto something. I think we should start raising our moon defenses. We need to collect asteroids and just put them in
We need to
orbit.
promote it back to a planet before it attacks.
Oh
We need to
man,
appease it.
that heart, that was just a tactic. That was like the Trojan horse. That Pluto, they're just trying to get into our good graces, and then it's gonna be like, bam, they're gonna like
Get us to
shoot
lower our
Hydra
defense.
right at us.
Yeah.
Exactly. Exactly.
All right, Sana, do you have the next one?
Yes, I do. And for this one, we're going to be going all the way back to 1572, November 2nd, which was, so maybe not exactly November 2nd, but around this kind of early November time period, which was when supernova 1572, also known as Tycho's supernova, actually occurred. So when we fast forward to now, or more specifically 1954, it was discovered that this event, Tycho supernova, was actually a supernova. But if you go back to 1572, when it actually happened and when it was observed by astronomers all over the world, they actually had no idea what this event was. So let's actually just imagine that we are astronomers in 1572 for a minute. You don't really know all that much about what is going on in the sky, or at least they didn't know anywhere near as much as we know today about our galaxy and our place in the universe. All of a sudden, this new star, this very bright new star, randomly appeared in the constellation of Cassiopeia, or Cassiopeia, depending on how you want to say it. And just for reference, at its brightest within a few days of the initial supernova event, this new star had a brightness of -4 magnitudes. For comparison, that's about as bright as Venus, and was also bright enough to be seen during the day for quite some time. So this was a really, really interesting event, and kind of shocking event almost at the time to astronomers who just randomly saw this new star appearing in the sky. Now, it was observed by a lot of different people because it was so bright. It could be really observed by anybody who was just looking in Cassiopeia and knew what the stars in that area looked like. but it's specifically named after astronomer Tycho Brahe as Tycho's supernova, because he did a lot of really groundbreaking work at the time using this supernova. About a year after the event in 1573, he printed a short paper on the object called Concerning the Star, New and Never Before Seen in the Life or Memory of Anyone, which had then been reprinted and edited based off of some collaborations that he had with other astronomers. So the reason why supernova 1572 was really so relevant at the time, and why Tycho Brahe is being specifically called out for this observation, is because he was the person who, of course, in collaboration with other people, sort of put the dots together that this event was not something that was happening really within our solar system. He kind of concluded at the time with a fair degree of certainty that this was something that was happening beyond the moon, so very far away from us, and showed for the first time in that time period that the stars that exist in our night sky are not static. They can change. New things can appear, things can disappear, and the stars can basically just change, which might be something that we kind of know and accept now, but at the time this was pretty crazy and caused a lot of astronomers in the 1570s to kind of rethink current models of our universe and our place in the universe. So yeah, this is definitely a very interesting discovery, not only because of what it did for astronomers in the 1570s, but also because this is one of the only a handful of very bright supernova explosions that have been recorded in human history. These things don't occur super, super often. So whenever one of them goes off, like supernova 1572, it is always a very noteworthy event. But it is now accepted that this event was actually a supernova, specifically a type 1a supernova, which is what happens when a white dwarf star, so the remnant of a sun-like star, is siphoning mass off of another companion star that are orbiting each other. So this white dwarf is basically pulling mass off of this star that is causing the mass of the white dwarf to increase. Eventually, it reaches the Chandrasekhar limit of 1.44 solar masses, at which point electron degeneracy pressure, which is what supports a white dwarf and makes it a white dwarf and stops it from collapsing in on itself, that degeneracy pressure is no longer sufficient to actually hold up the star. And you get this kind of runaway fusion reaction where fusion actually ignites inside the white dwarf, and it essentially just blows itself to pieces, creating that supernova explosion that was observed in early November 1572.
That was a fantastic thing to talk about. When I was looking through the possible events, I was like, oh, I want to talk about SN 1572, and then I looked up and I noticed that you'd already put it in the script, and I was like, oh, you beat me to it. This is fantastic.
Yeah, this is one of those really cool like historical sort of things that happened, where even though it was so long ago, it's just a really cool event in astronomy history, and learning about how astronomers sort of learned about what is going on in our universe and learning about our place in the universe, which is pretty interesting.
All right. I believe I've got the last item before we'll be moving on to the science section. This one is this one's also kind of tragic, but I do feel like I need to talk about it. So November 3rd, 1957, the famous Soviet dog Laika became the first animal to orbit the Earth. So Laika was a stray from the streets of Moscow who was launched into low orbit aboard the Sputnik 2 spacecraft. And at the time, little was known about the effects of spaceflight on an animal's physiology. Animal flights were viewed as a necessary precursor to human missions. Laika's vital signs were monitored over the course of the mission in an effort to verify that a living animal could survive being launched into orbit and continue to function under the effects of weakened gravity and increased radiation that are present in orbit. So the sensors showed her heart rate at 103 beats per minute prior to launch, spiking to 240 beats per minute during the early acceleration. It took 3 times as long for Leica's heart rate to return to normal than it had during the ground tests, which indicated that she must have been under a lot of stress in her weightless environment. However, she did continue to eat her food during this period. Tragically, Leica did not survive the flight, and in fact was never expected to, as the technology to deorbit hadn't been developed yet, so recovery of the spacecraft was impossible. The precise cause of Leica's death was kept secret for years, but in 2002, it was revealed that she died of overheating within the first 6 hours of the mission. Over 5 months after launch, Leica's remains burned up with the rest of Sputnik 2 as it re-entered the atmosphere on April 14, 1958. As tragic as Leica's story is, she is now immortalized as the first Earthling to enter orbit. What a good, brave girl. All dogs go to heaven, but some make a stop in low Earth orbit first.
Oh man, this one makes me sad every time.
Mhm.
Yeah, I think that now that I'm a dog owner, it hits me a little bit harder. I've always found Leica's story really tragic, but like now I'm a dog dad, so it's even it hits a little closer to home, you know?
Mhm.
No, being a dog parent, I think all of us are dog parents.
Yeah.
And
Are we?
it's
Yeah.
just, yeah. And it's just, because I'm like, she must have been so confused and she didn't know why she was
Mhm.
up there. And, the space flight was probably not super stable. So I hate thinking about it.
Yeah.
Yeah. I actually while I was doing research on this, I found a quote from one of the scientists responsible for sending Leica to space, Oleg Gazenko, and he said, "Work with animals is a source of suffering to all of us. We treat them like babies who cannot speak. The more time passes, the more I'm sorry about it. We shouldn't have done it. We did not learn enough from this mission to justify the death of the dog." And those words really hit me. Like this guy, this is a scientist who presumably would have had to do this work on the regular, and it still eats at him. It's I don't know. It's very sad. The history of space flight is not all victories. It's not all rosy new tomorrows and everything like that. There's a lot of sacrifices that go into that, and obviously, like we've talked before about like the astronauts who've given their lives, but at least they understand the risks. And it's unfortunate, like when you test space travel on animals, that's a creature that can't comprehend what's happening to it, doesn't understand why these things are happening. It's very sad.
Oh yeah.
Sorry to be a downer, guys.
Oh, it's
I
totally fine.
Yeah.
I couldn't not talk about Leica. I was
I
looking at
hope
the
Leica haunts somebody.
I hope so too. I hope so too.
It's definitely an
And some
important-
say you can still hear her. You can still hear her barking when you cross the Carmon line.
Oh. Yeah, it's definitely an important part of like space history to realize that uh even so many things in space now help humanity in so many different kinds of ways, and this is just like one of the important things that you have to talk about is, like you said, that there were a lot of sacrifices that went into this, so it's definitely not something we should take for granted.
With that said, we should move on to the next section. Now, Sana, did you have any announcements?
Yes, we have 2 reminders this week. So first off is a reminder for an observatory tour tomorrow, October 31st from 6 to 9 p.m. We're running a special Halloween themed tour called the Haunted Hydrogen Halloween, because hydrogen is the most haunted element in our universe. So if you would like to come visit the observatory and learn about why hydrogen is the most haunted element in our universe, stop by from 6 to 9 p.m. tomorrow. We will be doing live viewing with the 1-meter telescope, weather permitting. It is looking a little bit iffy right now about whether or not we'll be able to go through with that, so I can't make any promises, but it's not looking completely terrible for tomorrow. These events, as always, are completely free, but we do need you to sign up ahead of time if you're going to come out, just so that we know how many people are going to be coming and when. We're running tickets now on Zephy for this event, so just see any of our social media pages or our website for the link. And also, if you have want to come in Halloween costumes, you are more than welcome to, but just please be advised, nothing too big or bulky, because we do have a lot of sensitive equipment and small spaces up there. Did either of you want to do the second announcement, or should I?
I can do it.
Okay, sure.
Yeah, so on November 2nd and 3rd is when Jupiter is going to be opposition. So best views of Jupiter this year, since it's going to be closer to Earth than it is the rest of the year. So if you navigate to the observers page on our website and check out the Jupiter Moon tool and the Jupiter Red Spot Transit Calculator, you can see what moons are visible and if you'll be able to see the Great Red Spot when you're observing Jupiter. So this is really, really exciting. I'm really excited for the Jupiter opposition. Is the observatory doing any events in particular, or is it, or has it kind of created this web tool so that to facilitate like the individual observations that people might want to do?
I don't think we're running anything specific for Jupiter opposition, but those moon tools and the red spot transit calculator are they're run by, I don't remember who. It's a different web page, but if anyone is doing any kind of observing, our observatory observers page is a great place to look. There's a lot of different tools that run by different websites and everything astronomy related. So I'm just checking. It's Sky and Telescope that runs these Jupiter tools. There's also things like a Saturn moon tool and a Mars surface profiler. So if you are observing those planets either soon or at any time, you can always check those to see what moons of Saturn you're seeing and what features on the surface of Mars you would be seeing.
You have no idea how many times I've thought to myself, I wish I had a way of predicting what moons I might be able to see of Jupiter or Saturn or particularly, because I've looked through the telescope and I've seen the moons, but I can't identify which ones they are. And I'm like, oh, I wonder which ones these are. So I knew a tool like this must exist somewhere. I just hadn't found it yet. So this is fantastic. I'm saving this.
Yeah, it's really cool. There's a lot of also really cool links and stuff on our observers website. So I use it all the time for a variety of things.
All right, do we want to move on to the news?
Yeah.
Okay, fantastic. I think you're up first.
Yes. So this is yet another really cool piece of science that has come out of James Webb. So many other awesome science things that it's been doing recently. This time it's related to a kilonova explosion that happened on March 7th, 2023. So this kilonova was observed as a gamma ray burst. And basically what gamma ray burst or GRBs are is exactly what the name suggests they are. It's just a burst of gamma rays that comes out of a really energetic explosion. And essentially what happens in these gamma ray bursts is that something explodes in a pretty spectacular way, releases a whole bunch of gamma rays initially. These can last anywhere from less than a second to a few hundred seconds, and then are followed by an afterglow where the location where that event happened continues to radiate other kinds of light, extending all the way down from X-rays to even things like radio waves. And that can last for days to weeks to, I think, sometimes even months after the initial gamma ray burst. So while the gamma ray burst itself is definitely an important event to observe, the afterglow is equally important because it tells you some of the things that are happening around after that gamma ray burst, and also some of the things that happened during the gamma ray burst. Now, gamma ray bursts themselves are really cool and kind of, I guess, unique events. They do happen all the time simply because there are so many galaxies in our universe that have these gamma ray bursts going off. This gamma ray burst in particular, which is called GRB 230307A, is a particularly important gamma ray burst, I think, because it is the second brightest gamma ray burst that has ever been observed or recorded by humans. It's around 1,000 times brighter than most gamma ray bursts, and the gamma ray portion of this gamma ray burst actually lasted about 10 times longer than most other GRBs. So it makes it a pretty rare event, and one that was definitely worthy of being studied by a lot of telescopes, including James Webb. Now, the event itself happened March 7th, 2023. It was detected by NASA's Fermi Gamma Ray Telescope, which one component of that telescope literally just watches the sky for any potential gamma ray events that could be happening somewhere in our universe. It was then followed up with observations from a whole bunch of different telescopes, including the Chandra X-ray Observatory. It was also observed with radio waves and also in the near infrared by JWST. Now, the really interesting thing about this gamma ray burst, particularly from the James Webb side of things, is that JWST observations were used to detect the element tellurium in the afterglow of this gamma ray burst. So JWST observed this event twice after the initial gamma ray burst, once 29 days after the burst, and then another one 61 days after the burst. So both times it was targeting the afterglow of the gamma ray burst. It observed it using the near-infrared camera and near-infrared spectrograph instruments. The near-infrared spectrograph measurements actually was what made this detection of tellurium in the gamma ray burst. It ends up, so one thing I should probably also mention is that the combination of observations from JWST and the other observatories were enough for this team of scientists to determine that, first of all, this event was a gamma ray burst caused by merging neutron stars. And second of all, that those neutron stars had actually been ejected out of their host galaxy. Before the neutron stars became neutron stars, they were just two regular stars that were orbiting each other in a binary system. One of them ended up going supernova, kicked both stars out of their host galaxy. The second one eventually went supernova as well and kicked them further out of the galaxy. So they ended up around 120,000 light years away from their host galaxy, which for reference is about the diameter of the Milky Way galaxy, when the two of them ended up merging, creating that gamma ray burst. Now, by the time JWST observed them, it was able to find traces of the element tellurium in the spectrum of this gamma ray burst event object. And the reason why this is so significant to astronomy is just because all elements heavier than hydrogen and helium and tiny amounts of lithium were made in the cores of stars when they were evolving past their lifetime on the main sequence, or during really energetic events like kilonovas that create really, really strong gamma ray bursts. So this is a super interesting discovery. It helps us learn about how heavy elements like tellurium are created in supernova or kilonova blasts, and to learn about how those elements ended up on the Earth as well. So I think really cool for the two reasons of the first of all, these stars had been ejected from their host galaxy and were just sort of kicking around in space on their own. And also because, of course, you know, tellurium is cool, and learning about how heavy elements are created in our universe is also really interesting.
It's so crazy to me. Like, first of all, the fact that like all the elements beyond helium for the most part are created inside stars that's cool enough on its own. But then the fact that like you learn that nothing beyond iron gets created through like the normal fusion process. It's always through these extremely violent events, like neutron star mergers, like supernovas, like kilonovas. Like those, that's the only way to get those like really heavy elements. There's this extremely violent history to the entire like second. I want to say the second 3/4 of the periodic table. Just very, very interesting to me.
Yeah, that's that. I should have mentioned that. So I'm glad that you did. Is like that is part of what makes this really, really significant, is because that's the only way to make these elements. So it's really rare to be able to find an event that creates heavy elements. So another reason why this is such a cool discovery.
I have a news story as well. This one I think is interesting because we have an event that happened 66. We got an event that happened 66 million years ago, and it's still making headlines. So this is some more confirmation, essentially, of the Chicxulub impact being what led to the extinction of the dinosaurs. So The Alvarez hypothesis is the claim that an asteroid impact was responsible for the Cretaceous Paleogene extinction event, which wiped out all the non-avian dinosaurs 66 million years ago. Technically speaking, birds are dinosaurs, so they were able to escape. They were able to survive, but all the ones that we think of as dinosaurs were tragically removed from the Earth. And this explanation for the extinction of the dinosaurs was first proposed in 1980 by the father and son team, Luis and Walter Alvarez, and has since become the most well-known explanation for the extinction event. So in the geologic record, the Cretaceous Paleogene extinction event is marked by a thin layer of sediment called the KPG boundary, and it can be found within marine and terrestrial rocks all over the world. The Alvarez team were intrigued by this layer of sediment because it has this really unusually high level of iridium in it. And iridium is much more abundant in meteorites than it is in the Earth's crust. So this led the team to hypothesize that the dinosaurs went extinct, along with 3/4 of the plant and animal species on Earth at the time, because a very large asteroid had impacted the Earth. And this had tossed iridium-rich dust and ash into the atmosphere and choked out the sun for a prolonged period of time. So when the Alvarez team first came out with their hypothesis, they didn't know where this hypothetical asteroid landed. But in the 1990s, the hypothesis was strengthened when the 180-kilometer wide Chicxulub crater was discovered off the coast of the Yucatan Peninsula in Mexico. So this crater is the second largest confirmed impact structure on Earth, and it would have been formed around 66 million years ago by an asteroid 10 kilometers wide. So that is a very, very good indication that these two events are related. And this lent a lot of credibility to the impact hypothesis, but there were still conflicting hypotheses as well. The most well-known alternate explanation is that the dinosaurs were wiped out as a result of climatic changes caused by volcanic eruptions in what is now the Deccan Traps in India. So while many researchers are willing to accept that the Deccan Traps probably had some role in causing the mass extinction, we have no evidence that any other extinction events in the fossil record were connected to asteroid impacts at all, for example. The vast majority of evidence that has been collected since the 90s has strongly supported the asteroid impact as a deciding factor. The most recent development happened just today, October 30th, 2023. One of the biggest open questions was how long the debris from the impact would have been able to remain in the atmosphere. Would it have been able to block out the sun for a long enough period of time to cause a mass extinction on its own? And according to modeling performed by a Belgian team led by Kemberg-Bessel, dust particles the size of the ones found at the Chicxulub impact would have been able to remain in the atmosphere for up to 15 years, lowering global temperatures by as much as 15 degrees Celsius. The dust most likely would have been able to prevent photosynthesis entirely for the first 2 years. We already knew that the Chicxulub impact was devastating, but this is an important step further forward in quantifying just how much damage it would have been able to cause on its own. So it'll be interesting to see how our understanding of the global cooling period that would have followed the impact continues to evolve as we collect more data and develop more sophisticated climatic simulations.
So
What a crazy news event.
Yeah. There's lots
I
of
don't think we've
That
ever
came out
gone
today.
that far back.
Yeah, I think I might have set a record now for, I don't know. I think that maybe we might have an article about like the discovery of the Sudbury Basin. If not, I'm gonna add it to their roster because that's even further back. That
It's
impact
that-
happened before there was even like multicellular life.
It's that or like any story that we've done about the Big Bang.
Oh, true.
That's it.
Yeah, what am I thinking? Of course, the Big Bang. Yeah, we astronomers deal with some pretty pretty distant events in time.
Now, how am I going to beat the Big Bang? You think we can go farther than that?
What do you mean?
Pre-Big Bang news story.
I think we need to bring in some theorists for this.
We do. That's too abstract.
Yeah, that one might be a little bit above my pay grade. I think I don't want to speak confidently about anything. I don't even know if I want to speak confidently about the singularity, let alone anything that happened before that.
Yeah.
Well, this is one thing I can speak confidently about, and that's this upcoming story that I have for you guys. And I know
Yeah.
you guys will be able to relate to me with this one because we've had some weird experiences in the observatory. Our secret marshmallow stash for hot chocolate always going missing, nothing there when you need it, all the books getting rearranged out of order. But I did some digging, and I think there might actually be, I might have a theory as to why this keeps happening. So I
Yeah.
was on this forum from a really old forum for our observatory, a long time ago. And it was mostly just research questions. But then I came across this really weird thread. And apparently, 40 years ago, there was this really weird event that happened, not event, but occurrence. So there were these 3 grad students, and they were doing a pretty standard overnight observation. It was just of a variable star, like our standard research, and it was on our old 30-centimeter telescope, which is where the 1 meter is now. And they'd gone up to the dome to turn it around as their observations progressed, as we do. They didn't have the automatic dome back then, and they were adjusting a shutter. And suddenly, while all 3 of them were up on the platform with the telescope, the lights in the warm room turned off. And the only switch is down in the warm room. There's no switch up on the platform with us. So it was odd, but sometimes in the cold weather, things like that happen. So they wrote it off as an accident. They went downstairs, turned it back on. And then when they returned back up to the platform to change the dome was back in its original position. It had moved all the way back from where they changed it, and they had to move it again. This had never happened before. And to make matters worse, the door to the warm room slammed shut, and they got locked out of the warm room. So they had to go out through the main observatory door. They had to go all the way downstairs to the grad office, and they've had to find the spare set of keys and go all the way back upstairs, which is it's not far, but that's inconvenient. In the middle of your work, you get locked out of your room. So they get the second set of keys. They come back to the domes, and one of the guys said that on their way back through the tunnel, which for all of our listeners who haven't visited the observatory, the main observatory domes are connected by a 3rd floor walkway, a tunnel, it's suspended 3 feet in the air, nowhere to go. That's all glass.
Lit entirely in red light because you don't want to ruin your dark vision.
Exactly. All our white lights are off when you're observing, so it's all just red lights, and it's dark up there. And in there, they literally saw a figure, an apparition of a guy, and apparently he was dressed in a Victorian suit, and he was looking through one of those really old spyglass telescopes just out the window. And then they saw him, and then as quickly as they saw him, he disappeared. The only thing scarier than that is if they couldn't find the spare set of keys to shut down a telescope. But they were done for the day. They were we're not going back up there. We're not going to finish our work. They went up, they shut down the telescope. They said they had looming deadlines, and they did not care. They were we can't go up there today. They abandoned their night, and they shut everything down. And other departments, I guess they shared this whenever over lunch and stuff, and apparently grad students from other departments just wouldn't believe them. But all the astronomy graduate students were yeah, that checks out, because if you were going to go observe on Halloween, it came with a risk. Apparently you'd have books flying off shelves once in a while. And apparently they never saw that same figure again. But the dome has a tendency to close if you talk about him in the observatory. And I think Sana can attest to this because we have heard this pretty recently.
Yeah. There are our new domes have an auto close system on them to help us with weather. And there was once where we were standing in the dome watching it open, and we were joking about the observatory ghost. And it immediately, when we started joking about that, it stopped mid-open and started closing.
Yeah. So there have been a few whispers this week of some increased activity in the domes. And of course, tomorrow is Halloween. So good luck to whoever is on the night crew tomorrow. Stay safe. The scariest thing that could happen to a researcher right now is a ghost sabotaging your data right before the term progress meetings. So we got to be careful.
So
it's not going to be me. I'll tell you that. I'm not coming in tomorrow.
You're not coming in. I didn't sign up for tomorrow either. I didn't want to risk it.
I'll be there tomorrow visiting with our friendly observatory ghost if it exists.
Hey, the rule is 2 people in the observatory at all times, but on Halloween, you know you have somebody else with you.
Well, everyone, you have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Sana, Guggen, myself, Quentin, and possibly a ghost. You can always connect with us on Twitter with the handle @YorkUniverse, Instagram with the handle @YorkUobservatory, and Facebook at Allan I. Carswell Obs. And check out our website for show notes, content updates, and contact info at www.yorku.ca/science/observatory. Thanks for tuning into York Universe. Clear skies and happy Halloween.